Today we're going to continue our discussion of tree diagrams by entering in a page in our notebook just titled Tree Diagrams, and for me it is on page 53 and 54. At any point during this video, if I'm going too fast, feel free to pause it so that you have time to catch up. So then we'll have page 53 over here, which will be blank for now. We might use it towards the end of today. And then this page over here, 54, which is labeled Tree Diagrams. Now we use tree diagrams for compound probabilities, where there are at least two or more things that we are finding the probability for. And today, we're going to be looking at a spinner, which has a yellow section, a blue section, and a red section. And we're also going to be looking at a normal die, six-sided die. So those are the two things that we are going to be looking at. And we're going to practice doing a tree diagram for one compound probability, and this is the probability that we are going to be finding. So what is the probability of rolling an even number and spinning a blue, which is just the B that we have up there. So we're going to find what's the probability of rolling an even number on that dice and then spinning a blue on our spinner. Well, in order for us to come up with this, I'm going to have us draw a tree diagram down here, and I'll zoom out a little bit so that way we can see our problem and the tree diagram that we've got. Okay, so I'm going to start with a little mini self-portrait of me because I'm going to be the one down there. And first we are talking about what's the probability of rolling an even number. We're talking about the dice first. So up here I'm going to write dice, because that's what we're rolling first. We're rolling the dice before we spin the spinner. Now when I roll a dice, I could get a 1, 2, 3, 4, 5, or a 6. I could get any of those options. And here I'm going to start making my tree here. Those are all of the options I could get. 1, 2, 3, 4, 5, or 6. Now let's pretend I'd rolled a 1 on my first try. Second thing I'm going to do is using the spinner. If I rolled a 1 on my first try, on the spinner I could have gotten 1 and then a blue, could have gotten 1 and then a yellow, or I could have gotten 1 and then a red. That was one option that I could have gotten. But let's say I hadn't rolled a 1 first. What if I'd rolled a 2 first? Well, same thing. I could have gotten 2 then a blue, 2 then a yellow, and 2 then a red. It's going to get a little crowded on this diagram. Don't worry about that though. Let's say I had rolled a 3 first. Well, I could have rolled a 3, then spun a blue, 3, then a yellow, and 3, then a red. And let's take a look. If I'd gotten a 4 first, I could have gotten 4, then a blue, 4, then a yellow, and 4, then a red. For 5, same thing. 5 blue, 5 yellow, 5 red. And last but not least, if I had gotten a 6, could have gotten a 6 in a blue, 6 in a yellow, and 6 and a red. So these are all of the possible outcomes that I could have had from rolling the dice and spinning this spinner. One of the last things I want us to do is make a list of those outcomes, kind of like we did in our packets the other day. I want to write down what are all the possible outcomes. Well, let's see. I'm going to use kind of a dotted line here. I could have gotten a 1, then blue. I could have gotten a 1, then a yellow. Or I could have gotten a 1, and then a red. Here I could have gotten a 2 and a blue. Could have gotten a 2 and a yellow. Or I could have gotten a 2 and a red. And I'm just going to continue on doing this for all of the possible outcomes. 3, 4 blue,
Attention please, where the chair team is more
4 Y, 4 R, 5 and blue, 5 and yellow, 5 and red, and I'm almost done here. I could have gotten 6 blue, 6 and yellow, and 6 and red. Wow, lots of outcomes there. I'll zoom in a little if you were having trouble seeing that. There are all of our outcomes just from rolling a dice and spinning a 3-sectioned spinner. Lots of outcomes there. Now let's look back at the original question that it was asking us. It asked us, what is the probability of rolling an even number and spinning a blue? Well, that means I'm going to look in my outcomes to see which ones have an even number and a blue. And remember, our even numbers are 2, 4, and 6. That's what we're going to be looking for. So, let's see. These 3 have a 1. Automatically don't count. This one is 2 and blue. Hey, that's an even number and a blue. Let's circle it. This is 2 in yellow, not a blue. 2 in red, not a blue. These 3s here are not an even number, so I'm not looking at those ones. 4 blue, even number, blue. Let's circle it. 4 yellow, 4 red, those aren't blue. These 3 right here are 5s. That is not an even number. Then we've got 6, which is even and blue. So an even number and a blue. 6 yellow, 6 in red. And I kind of double check here to see if there are any other evens and blues. I don't think so. So when I'm coming up with my probability, there are 3 outcomes that match what it asked me. 3 of them over, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 3 out of 18 chance. And actually we can simplify this. Let's divide the top and the bottom by 3. And that will equal 1 over 6. So there's a 1 in 6 chance of rolling an even number and landing on blue with the spinner. Now, if you have time before we move on, you can go to page 53 here and try to set up a tree diagram to match this. If you don't have time, we will come back to this later.